Good morning. Today we're going to have a look at using our calculating trigonometry. I know that all of us are getting very good at that. I guess this, in particular, this review is about using our calculator when the degrees are in degrees, minutes and seconds. Now traditionally, as we might remember, degrees were measured the same as time in minutes and seconds. So it's the same as in time. There's 60 seconds in a minute, 60 minutes in a degree, and our calculator can give us our answer in degrees, minutes and seconds, but it normally, I guess, default is to give it to us in fractions of degrees. Now, the first thing is real calculator. So this is for the Abacus one. We need to make sure your calculator is set up so it's in degrees. So if I look at my Abacus calculator, which is this one here, I guess the important thing for us is just to know how to reset the thing. So if it's not in degrees, minutes or seconds, or if you've got stuff up here, we should just have math and D for when we're doing our problems. If we've got anything else up there at all, because people have been pushing buttons or buttons have gotten pushed accidentally, the way to reset it here is with this yellow clear. So the way to get the yellow clear, second function, 9 is clear. It says, what do you want to clear, the setup or the memory? We want to set up clear everything. So let's push 3. It asks us to make sure, do we want to? Yes, push equals. And then it's done it, reset all. So now we just push the AC key and it'll come back and we'll have those there. So it is very important when you start these sort of problems that you make sure that you've got it back here and you've got that little D there. You could have a rad here for radians. Radians are a different way of measuring degrees that we don't use in standard maths, but we do in advanced maths. And there's 2 pi radians in a circle instead of 360 degrees. And so as you can imagine, or might be able to imagine, if you have calculators in radians when you put in numbers where you think you're getting degrees, your answers would be miles out. Okay, so just review, 1 degree equals 60 minutes. Degree is that little circle, minutes is 1 stroke, with 60 seconds in a minute, and minutes are 2 strokes. So just going ahead, because it won't be any examples of this. If we look in here under Cambridge, they've got a heap of example here to get you the value of the following degrees in minutes. If you're going to convert them, you just put whatever degrees you've got in there and multiply by 60 to get it in minutes. If you're going the other way, whatever minutes you got, you divide the number by 60 and put your answer down as a degree. All right, so let's go. I'm not going to be doing any examples of that in our examples. If you get in there, you can do some of those. What we're going to cover is examples to do all of these things. Okay, so what I'm going to do today is I've got the booklet by my side. I'm not going to come backwards and forwards to here. This answer here is wrong. I still haven't changed it, but I will. So once you get to the 1 note, you'll find that it is different. As we know, sine and cos, the biggest value you can have is 1. I'm not sure what I did to come up with that. But what we're going to do is I'm going to go across to our calculator simulator, and we're going to put in these questions. All right, so we've got sine 60, sine 60. So with your calculator, it always comes up with a bracket here when we put sine, which is a bit handy. I like closing the brackets as well. 0.866, so we'd write it down to 3 decimal places, put our slash down, and then round it to 0.87. 2 cos 40.5, so that is 2 times cos. That's 40.5 degrees, so 40.5, close my bracket, equals 1.5208. So if I write it down there, my 3 decimal places, and then put a slash after the second, 1.52. Next one, 3 divided by 10, 75. You can do that 2 ways. You can either go 3 divided by, or you can put it in as a fraction. If we put it in as a fraction in the first place, 3, so your fraction's over here on the Abacus DE. It's in a different spot over here somewhere for the Casio, and it's got a box at line in the box. Then we can put in tan 75. We can go tan 75. I'd be inclined to close my brackets again. That's down there. So to get that to the normal position, you'd push that. But you should be able to just put equals from there. 0.803, 0.803. Put a line down there, 2 decimal places, down there. 0.80. Right, so sine 34 degrees in 20 minutes. So sine 34, and then what we've got is degrees. So DMS button here, DMS, and then we put in our 20. Now you'll notice in this one, if I just close my bracket, if I just push equal here, so let me just close my bracket even, I'm going to get an error from this calculator. It says a syntax error, and that is because we didn't have our minute thing in there. So this particular calculator, the Casio calculators as well, doesn't help you out with that. You need to make sure you put it in that second, that sign for the minute. So 34 DMS, 20, push DMS again, and it actually just gives us these things instead of dashes that look like it. Now we're okay. It finishes, it's in the right syntax, equals 0.564. Our answer will be 0.56. Okay, so let's have a look at these ones down here. Finding an angle from a trigonometric ratio. If you remember, we've been gone through that. To find that, we've got sine theta equals 0.6123. Theta equals sine minus 1. So on our calculator, second function, we can clear all that if we want in the first place. Second function, sine, gives me the sine minus 1. We have to turn it back on by the looks of it. Second function, sine. That's how you turn your calculator off, by the way. Second function, AC will turn it off. So you have to wait for it to go down. Second function, sine minus 1. What have we got? We've got 0.6123, 0.6123, close my brackets, equals 37.75. Find the value of theta to the nearest degree. Okay, for whatever reason in here as well, I changed that to degrees, minutes. So I wasn't paying too much attention. We just knew that to the nearest degree, so it would be 38 degrees. I might have to change that one as well and put it back in. Given 10 theta equals 1.45, find the value of theta to the nearest minute this time. So to the nearest minute, let's cancel it all and go with tan theta equals 1.45, so theta equals 10 minus 1. Second function, tan minus 1, 1.45, 1.45, close our brackets, equals 55.4. We need that in degrees, minutes and seconds. So this calculator, we just actually push the DMS, and if you just push that, it goes backwards and forwards between them. 55 degrees, 24 minutes. Now, there are 60 minutes in a second, so halfway is 30 minutes. So anything above 30 minutes is going to be rounded up. Anything below 30 minutes gets rounded down. 55 degrees and 24 minutes. The next one's sine theta equals 4 on 5, 5 theta. Once again, we are going to go, that's clear. Theta equals sine minus 1, 4 on 5. Second function, sine minus 1, 4 on 5. We can put it into our fraction, 4 on 5. So I'm going to close my bracket here. Really, I want to push that one there to get me up. Close bracket equals 53.13, finding it to the nearest degree, 53 degrees. Find cos of that to the nearest degree as well. So once again, we're just using an exercise to put that in. That's all clear. Second function, cos minus 1. Second function will get me to cos minus 1. Again, 1, the DE will get me into a fraction, square root of 2, root 2. Push this to bring me across, up and out. close my bracket, equals 45 degrees. Okay, so these ones here, again, it's just a calculator exercise. Sine 54, sine 54 degrees equals, I need to put my bracket in there, 0.8090. 4 decimal places, write it down to 5 in the first place, put your slash after the fourth, 0.8090. Tan 68.3, tan 68.3 equals 2.51288, slash after the fourth decimal place, rate after that rounds up to 2.5129. The last two are putting them in degrees and minutes. So cos 67 DMS 13, remember, up, push the DMS again, we can just push our equals, 0.38724, 4 is rounded down to 0.3872, and lastly, sine 11 degrees, so DMS 52 minutes, 52, bring out up here, equals 0.20563. Okay, so now have a go at those exercises in your OneNote under Cambridge and under Oxford. You shouldn't have too many problems with them hopefully today.